Welcome to the WVU Shared Research Facilities FTIR training module. In this training module, I will cover the basic operation procedure of the DigiLab FTS7000 FTIR spectrometer. Our FTIR is located in the Engineer Research Building, room 211. The entire system consists of a chiller, a power supply, a FTS7000 FTIR spectrometer, a UMA600 FTIR microscope, and a computer that operates the machine. In this video, I will focus on the FTS7000 FTIR spectrometer, while the operation of the FTIR microscope will be covered in a separated training material. Our FTIR is equipped with an attenuated total reflectance module, also known as an ATR module, as shown in the picture at the lower right corner. This module significantly simplified the preparation process for most samples. It allows you to directly perform FTIR measurement on samples without the need to prepare them into the transparent pellets, using the method such as KBR disk method. This flexibility is one of the main benefits of using an ATR module for FTIR measurements. Here, we are taking a closer look at the ATR module of our FTIR instrument. During a measurement, your sample should be applied directly onto this small diamond window. Next, the sample clamp must be securely closed. This action ensures good optical contact between the sample and the window, a crucial factor for achieving accurate results. The IR beam will be introduced from the bottom of the window. Upon encountering the sample, the IR beam reflects, carrying with the information about the absorption property of the sample. This reflected light is then collected and analyzed by the detector. The resulting spectrum is then ready for further analysis. Here, I need to point out that we will only need to close the sample clamp tip while performing the measurement on the samples. We usually leave the tip open when performing the setup and the background measurement. Since our system is equipped with a liquid nitrogen-cooled detector, it's necessary to cool down the detector with liquid nitrogen before the measurement. To do this, we first need to collect the liquid nitrogen, then apply it to the system. By now, you should have already completed the liquid nitrogen training provided by our safety officer. While in the following slides, I will walk you through the procedure of liquid nitrogen collection. After that, we will move on to discuss the operation of the system. First, you will need to locate the personal protective equipment required for collecting liquid nitrogen and the liquid nitrogen door. This can be found in room 211, next to the FTIR instrument. The PPE includes thermal gloves, face shield, lab apron. Additionally, it is important that you wear closed-toe shoes when handling liquid nitrogen. Next, gather all of the required items and proceed to the liquid nitrogen room located at ESB B44. Before beginning the liquid nitrogen collection, please ensure that you have put on the full set of personal protective equipment, as shown in the photo on the right. Subsequently, remove the cap of the door, then secure the door by positioning it inside the white bucket. This step will secure the door to prevent it from tipping over during the liquid nitrogen transfer. Then insert the transfer line completely into the door. Once everything is set, gently open the filling valve of the liquid nitrogen storage tank. Carefully dispense the liquid into your door. Ensure to pour slowly. This measured pace is essential both to prevent any spillage and to control the rate of liquid nitrogen boil-off. Once you have collected enough liquid nitrogen for the FTIR operation, usually more than half of the door's capacity, ensure to securely close the valve, remove the transfer line, and replace the cap on the door. Then you can safely transport the door back to room ERB 211. But please note that it is important to avoid using the elevator when transporting liquid nitrogen from ESB B44 to ERB 211. After getting liquid nitrogen, now let's get started with activating the system. First, turn on the system chiller. The blue chiller is next to the instrument table. You will find the switch at the back of the control unit. Go ahead and press that. Next, it's time to power up the system. The power supply is under the instrument table. Its power switch is also located at the back of the power supply. Give that a press. Now we are ready to add liquid nitrogen to the detector door. Begin by lifting the white instrument cover, spot the port, and remove its cap. You will want to insert a funnel into this port, taking care to ensure that the overfill port is directed away from you. Start adding liquid nitrogen slowly and keep an eye out for excessive liquid droplet emerging from the overfill port. This is the sign for you to stop. I want to emphasize that when we add liquid nitrogen to the door at room temperature, the liquid nitrogen will boil off very hard, creating a stream of gas exiting from the overfill port. It's crucial to understand that this gas stream does not indicate liquid nitrogen accumulation. Instead, it's a sign that the door is cooling down. Once the door is fully cooled, it will start to accumulate liquid nitrogen inside. Eventually, large droplets of liquid nitrogen will begin to exit from the port. This is the sign that the door is full and it's time to stop adding liquid nitrogen. Once that's done, remove the funnel and cap the port. Then close the instrument cover. Finally, let's get the ATR window and clamp tip cleaned. You will need wipes and IPA alcohol for this task. You could find those consumables on the sample prep bench in ERB 211. And here we have it. Our system is ready to go. The software we are going to use is called Resolutions Pro. Here is the main interface of the software. For our FTS 7000 spectrometer, all settings and operations are accessed via the Collect, then Rapid Scan tabs. Once we enter the Rapid Scan setting window, you will notice 5 tabs that will allow you to configure the spectrometer's parameters. This includes electronic setting, optics setting, advanced setting, background setting, and computation settings. And at the bottom of the window, we have buttons for measurements and instrument setup, including scan, background, setup, etc. In this slide, I have compiled all the necessary spectrometer settings to conduct measurements on a wide variety of samples. I have used the red arrows to highlight all the crucial parameters across the 5 settings windows. Please review them carefully and ensure you correctly input these parameters into their respective fields. A hard copy of this parameters setting slide is located next to the instrument as well. Now we have set all our parameters appropriately. Then we will need to perform the system alignment and the calibration. Here, we simply click the Setup button, which is located at the bottom of the scan window. Please remember that during this process, we will leave the ATR sample tip open as suggested earlier. After clicking the Setup button, you will see the system displaying its progress on the automatic alignment. Then the automatic alignment optimization in the lower left corner. This procedure can be somewhat slow and might take around a minute, so your patience is appreciated. Once completed, you will enter the Setup window as shown here. Next, proceed to the Calibration button and click it. This action prompts the system to conduct the calibration, which is a relatively quick process compared to the alignment procedure. The majority of this window is occupied by the center burst display of the FTIR system. Given that we appropriately set all the parameters, and after the alignment and the calibration, you should expect an intensity about 7 to 9 volts, as suggested in the upper left corner of the window. With both alignment and calibration completed, click on that OK button from the right, and this will bring you back to the scan window. Now we are ready to perform the measurement. In contrast to other spectrometers, such as UV Vis, an FTIR measurement typically involves 2 steps: capturing a background measurement and then capturing the sample's measurement. The background measurement records all the absorption features present within the instrument and atmosphere, including components like the water vapor and carbon dioxide. Later, the sample spectrum is compared with this background, providing an absorption spectrum that originated solely from the sample. To collect the background, leave the ATR sample tip open as suggested earlier. Then simply click the background button located at the bottom of the scan window. This will start a background measurement using the parameters previously selected. The resulting spectrum will be displayed in the measurement window, and in this scan, we will collect the background spectrum 128 times and get the average. And the progress of the measurement is indicated by the numbers on the right. Once the measurement is completed, the software will return you to the main interface, where you can assign a file name for the measurement. Now we are ready to load samples onto the ATR module. Let us go back to the close-up shot of the ATR module again. To load the sample, simply apply it to the small diamond window. Then close the clamp tip to ensure good optical contact. The ATR module can accommodate various types of sample forms, including powder, bulk, and liquid. They all follow a similar loading procedure. Let's begin with a powder sample. Apply a small amount of powder so it covers the diamond window. Then close the clamp by rotating the knob on top. The clamp is designed similarly to a fuel tank cap. Rotate the knob until you hear a click sound. This click sound signifies that the clamp is securely in position. For bulk sample, like films on substrate, we basically follow the same procedure. Remember that the IR beam will interact with the sample through the diamond window. So the surface of interest needs to face down to the window. For liquid sample, again, the procedure remains the same. However, ensure that you only apply a limited amount of liquid, just enough to cover the window. Be careful to avoid spilling an excessive amount of liquid across the entire module. Once the samples are in place, navigate to the Collect tab and then the Rapid Scan tab and click on it. This will bring us back to the Scan Setup window. Locate the Scan button and click on it to start the measurement using the parameters previously selected. The resulting spectrum will be displayed in the measurement window. In this scan, we will collect the sample spectrum 128 times as well to match the data quality of the previous background measurement. And the progress of the measurement is indicated by the numbers on the right. Note that this spectrum is the final result after comparison with the background collected earlier. Once the measurement is completed, the software will return you to the main interface again, where you can assign a file name for the measurement. Following this, you can open the sample clamp and clean both the window and the tip using wipes and IPA. The system is now ready for the subsequent measurements. Here, I would like to emphasize that the background spectrum in FTIR may change over time, which is often referred as thermal drift. To account for this variation and ensure the accurate result, it is common practice to frequently recollect the background spectrum after every significant break, before each new sample, or if you noticed unexpected features in the spectra. Now let's conclude our training session and go over the steps to wrap things up. First, make sure you save the entire project file and then export the desired scans into CSV file for further analysis. Then transfer the exported file from the FTIR computer to one of the kiosk computers in ERB 211. Then you could send those files to yourself using email. Please use those USB flash drive provided by shared facilities for data transfer. Now we can exit the Variant Resolution Pro program, and remember to check that all your data has been saved before doing this. Next, it's time to turn off the FTS 7000 spectrometer. You do this by shutting down the power supply. After the spectrometer is off, turn off the water chiller by pressing the switch on the chiller control module. Lastly, clean up your working area before leaving the room. This includes any sample residues, containers, and other materials you may have used during your session. Please remember that there might be some residual liquid nitrogen still in the detector door, but please do not attempt to remove this. Simply let it evaporate from the system naturally over time. And this concludes our training videos on using the FTS 7000 FTIR spectrometer. We hope this video has been helpful and encourages safe and effective use of the instrument. Thank you for watching.